folks, this is it. This is the last video of Chapter 5. Hope you're feeling good about it. I am. This one's going to be rough, so like I said at the end of the last video, brace yourself. This do now is not a preparation for a test, like the last one was. This one is directly related to the content that we're about to do. So if you skip the last one, don't skip this one. We're going to talk about how it's related to what we're going to do for the other two center points, the Circumcenter and the Orthocenter, and how it relates to finding those things on the coordinate plane. So here's a nice little review from Chapter 3, actually. I'm giving you a point, and I'm giving you enough information to find a slope, and then using a point and a slope, you're going to find the equation of some line. So let's do that. I want to find the equation of a line that is perpendicular to this thing that goes through that point. So being perpendicular to this red equation tells me something. It tells me that the slope of my equation is going to be the opposite reciprocal of the slope of this equation. So this red equation is already in slope-intercept form. We can see its slope is -3. So our slope is going to be the opposite reciprocal, so positive 1/3. Okay, so the way we would end up finding this line, our line, is that it's going to have a slope of 1/3, and it's going to go through this point. So if I put those two things together, if I start off with my shell of a linear equation, y equals mx plus b, and start plugging in the stuff I know, well, that's going to generate a new equation for me and let me solve for b. So 2 equals 1/3 times -4 plus b. Yes, this is gearing up to have fractions in it. Get tough, that's okay. -4/3 plus b. If I add 4/3 to each side, that's 2 4/3 equals b. So that's a weird mix of an improper fraction and mixed numbers. Let's get that out of there. 4/3 is 1 1/3. So 2 and 1 1/3 is going to be 3 1/3. So that's my b. So then all together, take the b that we have, take the m that we have, and put them together to make the equation y equals 1/3 x plus 3 1/3. If I try to graph this thing, if I start at the orange point that I know I'm on, if I use my slope of 1/3 to go up 1, right 3, I end up with a line that looks like this. Can I possibly do this right? No, I missed. Okay, good enough. We could actually kind of see that it does intersect the y-axis at what looks like 3 1/3, or what would be done better if I was able to draw a line straight. So, good enough. Keep this in mind, how to actually create an equation using a point and a slope, because we're about to do a crap ton of that. Ready? The orthocenter first, because the orthocenter is actually easier. There is not, unfortunately, a formula for the points, where we can plug in x and y coordinates and then have the coordinates of the orthocenter like ta-da. For this one, we actually have to use what an orthocenter is, which is to say that it is the intersection of the altitudes of a triangle. So what does it take to find the altitudes of a triangle? Well, just for one, if I sketch this guy on the right, I know that one of them is going to go through point F and be perpendicular to segment DE. So I know it goes through a point, and I could find the slope of it by acknowledging the fact that it's going to be the opposite reciprocal slope of DE. Alright, so to break this down, in a nutshell, finding the orthocenter involves finding two altitudes, altitude 1 and altitude 2, finding what their equations are by first finding the slope of a segment, using that slope to get the opposite reciprocal slope, and then using the opposite vertex to get an equation. So we're going to do that times 2 to get two altitudes equations. Then, on the next page, we're going to see where they intersect each other. Oh boy, like I said, brace yourselves. So we have to pick any two sides. I chose EF and DF because, well, why not? The first one's that we can get a good process down, and then the next one because DF is a horizontal line, so that should actually be easier for us. EF, okay, find the slope of that side. That looks like it's up 3, right 6. Okay, so that slope is 3/6, which reduces to 1/2. Okay, I'm going to use this area, by the way, to just be like my spare work area. Okay, so the slope of EF is 1/2. Therefore, the slope of our first altitude is going to be the opposite reciprocal of that, which is going to be -2. So now, D's coordinates are -5, 3. So if I want to find the equation that has a slope of -2 that goes through -5, 3, I'm going to plug stuff into y equals mx plus b. That's going to be 3 equals -2 times -5 plus b. So 3 equals 10 plus b. If I subtract 10 from each side, that's negative 7 equals b. Put it all together, and that is y equals negative 2x minus 7. Not too bad if you know what you're doing. And again, I highly recommend actually watching this video or like just pausing it on this page so that you know what to do when you're working on the worksheet. Okay, the next one is substantially easier because df is a horizontal line. Horizontal lines, refresher, have a slope of 0. Therefore, the altitude that I'm talking about, which would be this guy, has a slope that is undefined. But who cares? Because we know that this line, this altitude, is actually the y-axis, which has the equation x equals 0. So we didn't have to go through the whole y equals mx plus b shenanigans here. We can take a shortcut because vertical lines are special. So let's take these two things that we have here, these two altitudes, and then find where they intersect. See, I'm all prepared on this page. Let's find where they intersect. What I'm going to do is I'm going to take this x-coordinate of 0, plug it into the y equals negative 2x minus 7, and see what y value that generates. I'm going to get y equals negative 2 times 0 minus 7. That's going to give me a y of just negative 7. So, okay, what this means is that my point is going to be, and this point being the orthocenter, is going to be 0, negative 7. Okay, which would be, let's see, somewhere down here. That's negative 2, 3, 4, 5, 6, 7-ish. Good enough. So to kind of sketch this to confirm that it makes sense, if I were to extend DE and draw a perpendicular line from F, that works. If I were to look at this altitude, that appears to go through that point as well. And then if I were to extend the altitude through point D, that also looks like it's perpendicular to EF. So, hey, I guess it checks out. Especially because my drawings are typically pretty crummy. The fact that this looks like it's going to intersect right where it should be kind of confirms that, well, it doesn't confirm that 0, negative 7 is the answer. We could have made a mistake. Spoiler alert, we didn't. This is the correct answer. But just check to make sure that your answer makes sense in the context of the problem. It is also way down here because triangle DEF is a very obtuse triangle. Therefore, the orthocenter is going to be outside. So, hooray. Hooray for stuff making sense. 0, negative 7 it is. For the circumcenter. Oh boy. Okay. So take a second to think about this one. Don't get overwhelmed with it. Like, close your eyes and think. The circumcenter, actually close your eyes, ready? The circumcenter is the intersection of perpendicular bisectors. So we need to find the equations of some perpendicular bisectors. Perpendicular bisectors go through midpoints. You can open your eyes now, if they were ever closed in the first place. They go through midpoints. So imagine I'm looking at the perpendicular bisector that goes through AB. I'll find a midpoint, rough sketch now, and I'll find the perpendicular bisector that goes through it by using the whole opposite reciprocal slope thing. The 2 points I've chosen are, the 2 segments are AB and CB. So if I go to CB, find the midpoint, find the perpendicular slope, that makes the right angle, and then hey, it looks like my circumcenter should be like right about there. So another reason why we have to do it this way instead of just plotting stuff is that the circumcenter might have coordinates that aren't integers, so they might meet at some weird place like right here. Meaning we can't just look at the graph and say, oh, that's 1, 4, because no, it isn't. This triangle isn't right, so it's not on the triangle. And the algebraic way of doing it is the most precise. So let's think about what it actually takes to find the perpendicular bisectors here. So I'm going to pick a side. In this case, it's going to be AB. And I'm going to find the midpoint of it. So the midpoint of AB, that's going to be 4 plus 6 divided by 2. So 5, comma, 8 plus 2 divided by 2. So 10 divided by 2 is 5. The midpoint of this should be 5, 5, which, yeah, that looks about right. 5, 5 is the midpoint. Now if I want to find the slope of this thing, from A to B is down 6, from the y-coordinates 8 to 2 is 6, and right 2. So that's negative 6 over 2 as my slope, which reduces to negative 3. So, negative 3. And again, right below the graph here, like this area, I'm going to use this as my just work area, because I need some area for work. The perpendicular slope then is going to be, sorry, I shouldn't really call it the perpendicular slope. The slope of the perpendicular line is going to be the opposite reciprocal of negative 3, which is positive 1/3. So, alright, let's go to work. Y equals mx plus b. We're going to plug in 5 for y, I'm going to plug in 1/3 for m, I'm going to plug in 5 for x, and I'm going to plug in nothing for b, because that's what I'm trying to find. 5 equals 5/3 plus b. If I subtract 5/3 from each side, well, 5/3 is 1 and 2/3. So 5 minus 1 and 2/3 is going to be 3 and 1/3. Whoops. So 3 and 1/3 equals b. So therefore, my equation for line 1, which is really the perpendicular bisector, is going to be y equals 1/3 x plus 3 and 1/3. We have a whole way of handling this next time on the next page. What you could have done is you could have done stuff with improper fractions and blah, 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 blah. That's all good and gravy if you want to do that. However you end up getting b is up to you. There's also something that you learn in Algebra 2, maybe even Algebra 1, which is called point-slope form, which is a little bit easier here because we have a point, we have a slope. But I don't particularly remember talking about that, so we're just going to do it the old-fashioned way. For perpendicular bisector 2, I chose side BC, because why not, who cares? And if I want to find the midpoint of that, x sub m, m for midpoint, that's going to be 6 plus -2 divided by 2. So that's 4 divided by 2, which is just 2. The y-coordinate's going to be 0 plus 2 divided by 2, which is 1, which tells me the midpoint is 2, 1. Again, that makes sense. Looks like it's about halfway between C and B. The slope of this thing, I'm going to go up 2 and right, let's see, from -2 to 6 is 8. So that slope is going to be up to right 8. That's 2/8, which is 1/4. See, folks, I don't really need the slope formula if you have the visual. If you just recognize it as the rise over run, you could save yourself a lot of work. If I want to find the equation of this thing now, the fun part. Perpendicular slope first. The opposite reciprocal of 1/4 is -4, and then I can go to work here and find the equation. So y, let me go up higher. Y equals mx plus b, start plugging stuff in. That's going to be 1 equals -4 times 2 plus b. Remember, I'm taking the midpoint and I'm taking the slope because I know that this is the slope I'm using. I know that this midpoint is the point I'm going through. So if I use these things, I should be able to find b fairly easily. If I add 8 to each side here, I get 9 equals b, which gives me the equation y equals -4x plus 9. I promise we're almost done. See how I had this already here? So again, I want to see where these two equations intersect each other. So if you've done a system of equations before, there's more complicated ways to do this, but the best way to think about this is the transitive property. These are both going to be the same y-coordinates. So if this top y is equal to the right side of the top equation, this bottom y is equal to the right side of the bottom equation, what I could use is the transitive property to set these two things equal to each other. So I could say 1/3 x plus 10 over 3. 10 over 3 is the improper fraction version of 3 and 1/3, which is what we had in the previous page, equals the right side of the bottom equation, -4x plus 9. I could do this to solve for x, and then use that x to solve for y, and then that's going to give me the circumcenter. So how do I do this? This has fractions. That stinks. At least the fractions have the same denominator of 3. If I want to clear that out on an equation, what I can do is just multiply literally everything by 3, because doing so will clear out the denominators of the fraction. 3 times 1/3 x is just 1x. 3 times 10 over 3 is just 10. On the right side, we have to distribute the 3 there as well. To keep the equation balanced, we have to multiply both sides by this 3, right? That's going to be -12x plus 27. If I do some math, we start to see really quickly, if I add 12x to each side and subtract 10 from each side, like, holy moly, this thing's going to be ugly. This is a really ugly x value. That's going to be 17 over 13. Murphy, did you make a mistake? No, student, I didn't. This x comes out to about 1.308. And just so you know, your problems on the worksheet will not be this difficult. I promise. All the center points come out to coordinates that are nice. I think the worst fraction you get is 1/3. You might get a 1/2 and a 1/3 in there, but nothing like this. Nothing 13ths. So yeah, we are trying to find a circumcenter here, which is a point, which means it has an x and a y. So how do I find the y that goes with this x? Well, I could plug it into either equation here. Which one do you think is the better one? Probably the one without fractions, the blue one. Yeah, that top one stinks. So if I plug 17 over 13 in for x, I'll get a equally ugly y value. I'll get y equals -4 times 17 over 13 plus 9. Oh man, you guys probably hate me right now. This y is going to be equal to, timeout, I'm going to cheat with my calculator, equal to approximately 3.769. So Murphy, why have you done this? Why have you given us such ugly numbers? Well, student, I'm doing this because this kind of demonstrates the fact that we can't always just use a graph and visually take a guess about where stuff is, because we don't know the exact coordinates, and algebra is more precise. And second of all, because if we can handle this, boy, you can handle just about anything, I think. Again, the coordinates on the worksheet for the center points are going to be much easier, much better to work with. So if I were to actually graph this thing, suppose I did try to graph the perpendicular bisectors. There's one, there's another-ish. It looks like they're meeting at, hang on, something like this. And if I take into account the fact that I drew this pretty roughly, the x-coordinate is clearly between 1 and 2. The y-coordinate is clearly between 3 and 4. So again, this stuff checks out. Use common sense and what knowledge you have of these terms, the Circumcenter, to make sure that your answer makes sense in the context of the problem, even with a rough sketch. So anyway, if you need help with this, by all means, ask. And don't wait, well, I guess if you're watching the video now, you either did or didn't wait to the last minute, but I hope not, because this could be something that we could work through together if you need to. It gets a little bit tough, but if you've seen this, this is the worst of it. The worksheet's quite a bit easier. So, wow, that's the end of Chapter 5. Oh, it's so bittersweet. I hope you've enjoyed it. I hope you've enjoyed the whole self-paced unit thing. We'll see if there's more to come in the future. But for now, without this video going overboard, ta-ta.